Welcome back from the ad break, guys. Before the ad break, we went through various types of questions for calculus. Now, let's go back and do some more. The next question says, determine the following, leave your answers with positive exponents. F prime at x, if f at x is equal to 1 over 2 the 4th root of x cubed. Now already there, people start panicking. Don't worry. The first thing we need to do is convert this into an exponent that we really understand. Remember this rule? I'm going through it again. So it's the inside of the power divided by the root. So let's apply that rule to this. The inside, which is 3, divided by the root, which is 4. Now all we need to do now is take this upstairs. Remember the rule for taking upstairs and downstairs? So you can use it from either left to right or right to left, it doesn't matter, vice versa. So then you'd have a half x minus 3 over 4. Now we can find our derivative. So we multiply this into there. You have a half multiplied by negative 3 over 4 x now remember when you multiply fractions, multiply the top with the top and the bottom with the bottom. So 1 times 3 is negative 3, 2 times 4 is 8, and there we need to subtract 1. So minus 3 over 4 minus 1 would give you minus 7 over 4. So you could actually do that on your calculator. Now, remember the question said, leave your answers as positive exponents. So we need to get this to be positive. So we bring it downstairs and it becomes a positive. Now guys, we've done about 3 where we had to work with powers that were fractions. I know everybody hates fractions, but the more fractions you do, the better you get at them. And you kind of guarantee that you will get one with a fraction because they really need to test your ability. So practice more fractions and then really go back and do these questions again and again. Let's go on to the next question. The next question is a start of a section of calculus which is called applications. But let's really look at it. Determine the equation of a tangent to f at x equal to x squared minus 6x plus 5 at x equal to 2. Before you can even attempt this question, guys, you need to ask yourself, what type of graph is this? It's a parabola. So let me really explain to you what it really means. Okay. If I had to draw this question for you, this is the parabola. It's got x-intercepts at negative 1 and 5, negative 5. So say there and there. And we need to find, okay, we'd have to extend it even more because we need to get it to come all the way to cut your, there we go. So there. So we need to find now the tangent at x equal to 2. Now let me just draw the tangent in a different color for you so that you can actually see it. So if this, say this, was 2, then your tangent would be there, right? So it would be a line that goes through there. No, it's not straight, but you get it. Let's just redraw it so it looks better. There we go. And our tangent is there. So there's our tangent. cuts there at x equal to 2. We now need to find the equation of this yellow line. That's what we're looking for, the equation of the yellow line in essence. So let's see. If you remember now in algebra when we had to find the equation, step 1 is you need to find the gradient, or m. And remember in calculus, the gradient is actually the derivative. So we have there f at x equal to x squared minus 6x plus 5. So, and we need to find the gradient at x equal to 2. So we first have to find the derivative. That would be 2x minus 6. Then find the derivative at x equal to 2. And that would be negative 2. Now we've just found our gradient at x equal to 2, which is negative 2. So if I had to go back to the sketch quickly, our gradient of this yellow line is minus 2. It's not a point, it's the gradient. In other words, it's the slope. Now let's go back to the question. Now that we've found the gradient, we can go on to step 2. Step 2 is to find the point of contact. Now the point of contact is, in other words, this point here. We only know the x, we don't know what the y is. So we need to find the y. And we can't assume, remember my picture, my sketch, guys, is drawn freehand. So we can't assume that it is at 0. We need to actually prove whether it is or is not at 0, because my sketch is not to scale. So to find the point of contact, we would then have to substitute 2 into the original question, which is this question here, this one there that we were given. So 2 squared minus 6 times 2 plus 5. So there, we can use our calculator for that to put it all at once into the calculator. Let's just say, so that's open bracket 2 squared minus 6 times 2 plus 5 minus 3. So there we go, it's minus 3. So that means then our point of contact is 2 minus 3. Remember, guys, we did a question very similar to this earlier, where they said, what does this point represent? This represents your y coordinate. In other words, this is your x, this is your y. So we're almost there, one more step to go. Now the third and final step is now to find the equation. And we use this equation here. This formula is on your formula sheet. So y minus y1 is equal to mx minus x1. And you'll see it in this form on your formula sheet. So we now have our y. It's minus 3. We have our m, which if we go up and look at it quickly, it's minus 2. And we have our x, which is 2. Let's get rid of those brackets. Negative times a negative is a positive. Multiply that into there. Negative 2x. Negative times a negative again is a positive. Now, let's just get everything to one side, or rather the y on one side and the rest to the other side. Take this over. Remember, when something comes over an equal sign, it changes in sign. And if you add those two apples with apples, you get that. So then the equation of this line here is y is equal to minus 2x plus 1. And that's the question. There is your point of contact, that minus 2, I think it was 3, right? Minus 2, yes, that's 2, 3. That's your point of contact. So now you know. Let's go through the steps again quickly. To find the equation of a tangent, step 1, we find the gradient, and we find the gradient by finding the derivative. And then substituting your point of contact, or your x part, which is 2 in this case. Step 2, you find the point of contact. Now you only were given the x, so you need to substitute the x into the original, which is f at x, to get the y. And their point of contact was 2, negative 3. The last step, but quickly guys, actually I need to say this. Sometimes they may give you the point of contact. They may give you a point 2 at 3. So then you wouldn't have to do step 2. You just go from step 1 to step 3. Step 3 says, find the equation. So we use this equation, this formula, y minus y1 equal to mx minus x1. We substitute our m that we know, our x1 we found earlier, and our x1 we were given. And there, we collect all our like terms, and our equation is y equal to minus 2x plus 1. Now guys, we've gone through basically most of calculus, but we need to now go back to our checklist and see, have we done everything? And most importantly, do you understand? Our checklist. Make sure that you can use first principles to find the derivative of a function. Now, remember first principles is this formula. The limit as h tends towards 0, f at x plus h minus f at x all over h. But one thing you also need to remember is that you can check your final answer using the rules. So after you're done with the question and you're satisfied and you think, I've got it, check using the rules quickly on the side, and if you get the same answer as your first derivative, then you should be happy, doing the happy dance, then you're good. The next one is rules of derivatives. Now the rules of derivatives, there's 3 in your booklet, but there's actually a bit more than that. And throughout the sessions, I've been trying to go through into them in detail, but I'll recap them now again. Remember, the first rule says that if you have f at x equal to x to the power of n, then your derivative is nx subtract 1 from the power. The other one says that if you have f at x equal to a constant, in other words 1, 3, 5, a number, then the derivative of a constant is 0. Then the other one has got more to do with exponential rules, that anything to the power of 0 is 1. Don't forget your other exponential rules. Remember, if you multiply same bases, let me just write it out like that for you now. Then you add the powers. We use that in one of the questions. Also, another one is the root one that came up quite often actually, is that you then divide the inner power by the root. And this is one thing you should really learn, that all the sections in paper 1 are actually interlinked. So you need to know your exponents and your algebra in order to do your calculus. Now we're going to interpret the different notations for derivatives. Remember guys, there's more than one way of being asked a question, but you've got to know what they're asking you for. The different ways to ask for a derivative are f prime x. They could say d subscript x, that means little x, and they have square brackets and the question inside. They could also say dy dx. And this in essence all means find the derivative, which also means find m, or the gradient. Remember also we did two types of ways. We did gradient at a point, which is really find the derivative, substituting that point that they gave you, whatever it may be, and then finding your m, or your gradient. We also did average gradient. And this was when we used m equal to y2 minus y1 over x2 minus x1. So we found the different points. We found y1 by substituting x1, and we found y2 by substituting x2, and we substituted into this equation to get your m. One of the final things we also did was finding the tangent to a curve. Finding a tangent to a curve, it could be any curve, guys. And you'll see also later when we do more calculus and applications, it could have been a parabola, it could be a cubic, it could be anything. So a tangent is a line. Let's choose a different color so you can see where it is exactly. There. It just touches the graph. So it could have been there. Oopsie, that's not so nice, but could have been there. So that's what a tangent is. I gave you 3 important steps. Step 1. What was that? Find the gradient. Or m, which is also the derivative. Step 2 was finding your point of contact. And that we did by substituting your x that you were given into your original formula to get your y. Step 3, and the final step, was find the equation using y minus y1 is equal to mx minus x1. And there. Now we've just laid down the foundation for calculus. Next time we'll be building onto that foundation, doing applications with calculus. So join me for that session. From me, Mawatu Mukiti, the Mathemaniacs. See you next time.